friends, Mrs. McBride here, coming to you straight from my office. What we're doing today is we're talking about something called VIRPing, V-I-R-P, which you all know that VIRP stands for voltage, current, resistance, and power, but this is a good way for us to organize all of our information. Now, what I did is I posted these note pages for you. That way, if you want to print them and fill them in, it's up to you. If not, go ahead and draw the chart. You don't need to necessarily draw the circuit if you follow along with me. This is a great time for you to follow along and really pause the video and see if you can do it on your own, okay? But first things first, what do you get when you cross a dentist and a boat? A tooth fairy. All right, so here we go. So what we're gonna do first is, when you look at this circuit here, you should be saying to yourself, aha, this is a series circuit and there are 3 resistors here, a 3 ohm, a 10 ohm, and an 11 ohm. Now I just picked these randomly, okay, there's no significance here. So this resistor is the 3 ohm, this is the 10, and this is the 11, okay? And what I want you to do is VIRP it, meaning that we're gonna fill in all of the different parts. And I also want you to tell me, what is the total voltage, or what is the voltage on the battery? Now, as a reminder, in a series circuit, what is the same throughout? You should be saying the current, okay? And the voltage adds up, okay? So here we go. So first thing I would do is I would say, okay, this is pretty nice. I gave you that the total current, or in this case, the current in each piece is 2 amps. Okay, so I'm gonna start by writing out that the current in each piece is 2 amps. Perfect, right? Okay, now the next thing we need to do is we need to figure out the voltage. Well, if we use our equation V equals IR, that should be really easy to find the voltage in each piece, right? So the voltage here, it would be 2 times 3 or 6. And the voltage in R2 would be 20. And the voltage in R3 would be 22. Okay? Wonderful. Okay, the next thing we need to do is find P. Now, as a reminder, IVs give you power, or current times voltage gives you power. Okay, so we should be able to say that to find the power through resistor 1, it would be 6 times 2, or 12, 20 times 2, or 40, and 22 times 2, or 44. Okay, the last question I would ask you, so now we've officially VIRPed it. What is the total voltage? Well, as a reminder, in a series circuit, you find the total voltage by adding up all the voltages. So we would have to do 6 plus 20 plus 22, or in this case, we would get 48 volts. All right, pretty easy, right? Let's kick it up a notch. Here we go. Okay, so in our next circuit here, let's take a look. So we've got 3 resistors, 13, 35, and 33. Those are the hockey numbers of everyone in my family, okay? So we've got 13, which is Nora, 35, which is Nate, and 33, which is Mr. McBride, okay? And it gives me the total voltage. It does not give me the current. So this one is a little bit more complicated, right? Because I can't put something here, but it does want to know, what is that total current? Okay, so how would I find that? How would I find, basically I want to find the total current, because then I could put it in each piece and then I would be all set. So we have 2 equations to find the total current, right? We know that IT equals I1, equals I2 equals I3, but the problem is we don't have any of those I's, so this one won't help us. We do know that VT equals IT times REQ, okay? So what is the total voltage? Well, it says the total voltage is 40.5. The total current, we don't know. And REQ we can find. How do you find the equivalent resistance in a series circuit? Well, hopefully you're saying REQ equals R1 plus R2 plus R3, or in our case, 13 plus 35 plus 33, which I totally do not know off the top of my head. 13 plus 33 plus 35 is 81. Okay, so REQ equals 81. So in this case, REQ is 81. Okay, so IT is 40.5 divided by 81, or in this case is 0.5. Okay, so what do we do with this? Well, the nice thing is that the total current is the same through each piece, right? All right, good work here. Okay, so now what we're going to do is we can find the voltage by again using that V equals IR. Okay, so what is 0.5 times 13? Okay, well hopefully you are saying that this is 6.5. Okay, what is 0.5 times 35? Hopefully you're saying 17.5. And last but not least, 30 times 0.5 should give you 16.5. Now, how do I know I'm right? Well, if I take 6.5 plus 17.5 plus 13.5, I should get 40.5. So that's a good way to check yourself, right? And if you add all these up, you should notice that that works. Okay, and last thing, we need power equals current times voltage. Now I'm going to have to use my calculator for this. So I'm going to have to say 6.5 times 0.5. In this case is 3.25 is the power. Okay, and 17.5 times 0.5. Okay, I get 8.75. And last but not least, 16.5 times 0.5, I'm getting 8.25. Okay. All right, and we have officially VIRPed it. And the last question that we have here is, what does the ammeter read here? Well, the ammeter here reads 0.5 amps. All right, let's spice it up here. Let's go parallel. Okay, so when I look at this, I say to myself, aha, this is a parallel circuit with 3 resistors here of 3, 4, and 5. Okay, and it wants to know what is the reading on the ammeter. And it's telling me that the total voltage is 60. Now let's recap. What do we know about a parallel circuit? Well, we know that the voltage is the same through each piece, and we know that the current is going to add up. So here we go. So if the voltage is 60, that means that the voltage in each piece is 60. Okay? Now, what if I want to find the current? Well, again, if V equals IR, then V divided by R should equal I, right? So if I have 60 divided by 3, that should get me 20, okay? And if I have 60 divided by 4, that should get me 15. And 60 divided by 5 should give me 12. Okay? Now, let's go ahead and find the power. Power equals current times voltage. Now, if any point here you want to stop and calculate on your own, go for it. Okay? All right. So power equals current times voltage. So 60 times 20 would give me 12,000 watts. That's pretty powerful, huh? This would be 60 times 15, which is 900 watts. And last but not least, 60 times 12, which would give me 720 watts. Now, do you notice I didn't put units on any of this? I just think it makes it more complicated. Okay, and last thing here, it wants to know what is the current. Okay, so this here is reading the total current, and remember that in this case the total current adds up. So we would take 20 plus 15 plus 12. If I do 20 plus 15 plus 12, this gives me 47 amps. And this is just not a very realistic problem because that is a way too high value for current. That would kill you here, friends. All right, now here's what I want you to do. Here's where you're going to practice on your own. So I would really like you to stop this video and practice on your own, okay? So I'm gonna get you set up here and say, first of all, this is a series circuit. We'll put 4 and 5 and 6 here, okay? It gives me the total voltage. I'd like you to stop, okay, and try it on your own. If you need help, here we go. Okay, so the first thing we need to do is find the total current. So we're going to say that VT equals IT times REQ. Okay, we need to find REQ by taking 4 plus 5 plus 6. Okay, so 4 plus 5 plus 6 gives me 15. So the total voltage is 30. REQ is 15. Or this gives me a total current of 2. Okay, and since current is the same, we go 2, 2, 2. Okay, now, I'm also going to start by saying that the ammeter here is reading 2. To find voltage, we do V equals IR, okay? Or in this case, we get 8 and 10 and 12, okay? And as a check, we say 8 plus 10 plus 12, does it equal 30? It does. Okay, and to finish VIRPing, we use P equals IV. Okay, so I times V here is 16, 20, and 24. Okay, hopefully you got this one right. Great. Okay, last one in our practice set is this one here, which says this is a what type of circuit? I hope you're saying parallel, okay? And we've got resistor values of 2, 4, and 6. And a total voltage of 12. So since this is a parallel circuit, the total voltage for each one is the same. So we get to write 12, 12, and 12 there, okay? And again, if V equals IR, okay, then I is going to equal V over R. Okay, see if you can finish up on your own. To find the total current, we do 6 plus 3 plus 2, or in this case, it would be 11 amps. Okay, and last but not least, to find the power, we take 12 times 6, which is 72. 12 times 2, which is, oh, sorry, I don't know where I went crazy there. 12 times 3 is 36, and 12 times 2 is 24 watts. All right, hopefully this makes sense and you had no problem VIRPing it. The next thing that you need to do is take a little quiz assessment that's on the Google Sheet that looks just, or excuse me, the Google Doc that looks just like this. And then you can go ahead and submit it and I will grade that for you. If you have questions, I'll be on Meet on Thursday at 3:30. Bye, friends.